For this video, we'll be going through electrical system. This is for your LSS science on electricity, exercise 4. Okay, let's start. The same cell is used in each of these circuits shown below. The current is the same. So if I have the same cell, that means they have the same voltage, okay? And then they tell me that the current is the same. Now the formula to apply is V equals IR. If the voltage is the same, the current is the same, that means R must be the same for both circuits. So for these two for the circuit on the left, the total resistance REFF is actually 4 plus 3, because in series we can just add them up, so it's 7 ohm. Therefore my R over here must be 5 ohm. Okay, question 2, in the circuit shown below, the reading on the ammeter is 3 ampere. That means I have a current of 3 ampere, I have a current of 3 ampere, current of 3 ampere, 3 ampere, 3 ampere, 3 ampere, and 3 ampere, right? So what am I trying to do here? I'm trying to show you that in series, the current is the same. Okay, current is the same. And current always comes out from the positive terminal back to the negative terminal. Okay, so they want us to find out the reading on the voltmeter. So this is my voltmeter, and this is the circuit symbol for the voltmeter. You need to be able to draw this. What are they trying to find? What does the voltmeter measure? The voltmeter measures voltage. Okay, or another word for voltage is potential difference. So if it's measuring voltage, you need to know what is voltage represented. It is V. Okay, the formula that we use again is V equals IR. So they want us to find V, and we know that the current that passes through it is 3 ampere, and the resistance, in this case the voltmeter is measuring the potential difference across the 6 ohm, right? Because the two legs are connected across the 6 ohm. So the resistance here will be 6. Therefore, the voltage will be 18 volts. Okay? So you need to know this formula V equals IR, and you need to know the current and the resistance. So the voltmeter, if I were to extend this question a bit, what is the voltage across the 2 ohm resistor? The current is 3, the resistance is 2, so it will be 6 volts. For this 4 ohm, what is the voltage across the 4 ohm resistor? Again, the current is 3, because in series, current is the same. Multiplied by the resistance, which is 4 now, it is 12 volts. Okay? So this is the voltage for the 2 ohm, voltage across the 4 ohm, and the voltage across the 6 ohm. So if I were to add them up, 6 plus 12 plus 18, I will get a total voltage of 36 volts, which means the battery is 36 volts, right? The battery is 36 volts, so that it can supply the voltage of 6, 12, and 18 to the 2, 4, 6 ohm respectively. Okay, how can I prove that? Now, you know that in a series, the resistance are connected in series, right? So I can actually find the REFF. The REFF is actually 2 plus 4 plus 6, like the previous question. So I will have a total resistance of 12 ohms. And I know that the current is 3 ampere. So I have my I have my R. So I can actually calculate the voltage to be V equals to IR, which is 3 times 12. So I will have 36 volts, which is the same answer as what I have done just now. Okay, so this is just an extension to this question. Okay, question 3, an electrical component S, which is here, is connected in the circuit as shown, and we see that there is only one path, right? The current don't actually passes through the voltmeter, so there's only one path, so everything is connected in series. So what does S represent? It represents a variable resistor, or we can also call it rheostat. RHEOSTAT. Why is it included in the circuit? Now, what's the purpose of the rheostat? Basically, it is a variable resistor, which means the resistance of it can change. So if you look at your V equals IR, and if my V is constant, my R, I can go up, I can go down by using the variable resistor. It means that I can control the current. Therefore, the purpose is to control the amount of current in the circuit by changing its resistance. Okay, so where do I use this variable resistor in real life? If you have a fan, you can actually change the speed of the fan. How do I change the speed of the fan? By turning a knob. So the knob will actually change the resistance. If I have more resistance, I will have less current, right? V equals IR. If my resistance is higher, my current will be lesser. That means the fan will spin at a lower speed and vice versa. Okay. Now question 4, the following circuit shows a battery of 6 volts, which is here, joined to two resistors and an ammeter, assuming that the battery and ammeter have negligible resistance. That means we don't need to consider their resistance. Calculate the total resistance. Now, how are the resistors connected? They are actually connected in parallel, because if current comes out, it comes to this part, it will have to go to two paths. So there is actually a split, right, before they join back. So they are connected in parallel. So this is the first thing that you need to know, that whether is it series or parallel. You can do this by role playing the current, see if there's any path, extra path that they need to split. Then you need to recall the formula, the effective resistance. It is, for parallel, is 1 over R1 plus 1 over R2. Okay, so what is my effective resistance? I can choose R1 to be 3, it doesn't matter. Then I'll choose R2 to be 6. I do my fractions. I will get 1 over REFF equals to 2 plus 1 over 6, right? So it will be easier if you have a calculator. Now, why do I keep writing down 1 over REFF? Because I will need to remind myself that I need to flip. So let me do the fraction first. 1 over REFF equals to 3 over 6 equals to 1 over 2. You can simplify it, okay? But I'm not looking for 1 over REFF. I'm looking out for REFF. I'm calculating. So I flip both sides. My REFF equals to 2 over 1. So it is 2 ohms. Okay, that means I can replace this circuit by a 2 ohm resistor. That is what it means by effective resistance. Okay, so after I have found the effective resistance, and if you redraw the effective resistance to replace these two resistors in parallel, you'll find that the circuit is actually simpler. Okay, now what reading will the ammeter show? Ammeter will actually measure current, right? And current is not it's not A, it is I. Okay, and if I have the resistance, right, which is 2 ohm, right? For part A, they ask you to find the resistance, so I can use the effective resistance here by using the simpler circuit on the left. I have the V, this is my V. I can actually calculate the I using the formula V equals to IR. So I will have 6 equals to I. I will use the effective resistance of 2. Therefore, my current is 3 ampere. Okay? So you need to know what is your V, I, and R. You need to know their units. Now, will the addition of an extra resistor in parallel with the original resistors increase or decrease the current drawn from the battery? Explain your answer. So, which means to say they want us to put in another resistor. Initially was 3 ohm. Then I have 6 ohm. And now they want me to add one more resistor. Okay, so the more resistors in parallel, okay, the lower the effective resistance. Okay, the lower the effective resistance. So if here is let's say 10 ohm, then I'll actually do a 1 over REFF equals to 1 over 3 plus 1 over 6 plus 1 over 10. Okay, and if you do your math, you'll find that this REFF will actually be less than the 2 ohm that we have calculated over here. Okay, you can try it out. So this is a conclusion, and it is a law, it is true. The more resistors in parallel, the lower the effective resistance. And if the effective resistance is lower, using V equals to IR, the R effective resistance decrease, right? Therefore, the current will increase. Okay, so it will increase the current if I were to add in another resistance. Why? Because adding another resistor in parallel will decrease the overall resistance or the effective resistance. And then since V equals to IR, my V is fixed, my R decreases, therefore my I increases. Okay, so this is for worksheet 4.